Good afternoon, everyone. Just a quick check. Any of the other panelists, make sure you guys can hear me.
I can,
You're,
Ryan.
you're good.
Oh, perfect. All right. Well, I'm Ryan Stiggy. I'm the program manager for decarbonization, and welcome to our fourth Pathways to Decarbonization workshop. I hope that you were able to join us for the past three workshops. If not, they are available for viewing at oppdcommunityconnect.com. And this workshop will be recorded as well and available there after it's over. I'd like to acknowledge with us today, we have Mary Fisher, our President of Energy Production and Nuclear Decommissioning and the program sponsor. And thanks to any other elected officials or community leaders that are joining us today. And thanks for your support on this endeavor. So today's workshop really builds on the previous three workshops and digs into how we're approaching reliability and resiliency, as well as the economic modeling and optimization. So these topics combined with our net zero goal really embody OPPD's mission to provide affordable, reliable, and environmentally sensitive energy services to our customers. So today you'll hear from Colton Kennedy, Steve Homan, and our vendor partner E3. So Colton is the manager for corporate planning and is the project manager for the energy portfolio project. You've heard extensively from him over the past three workshops, and today is no different. Steve Homan is a senior transmission planner, and he's leading the reliability and resiliency core team that is within the energy portfolio project. And as you'll hear today, reliability and resiliency are key parts of the decarbonization study. And Steve and his team have really been doing a tremendous amount of work. So again, thanks for joining us, and we encourage your interaction with the team throughout the workshop today. Let's go to the next slide. All right, so we begin every meeting with a safety topic that is a top priority for OPPD, and this meeting is no different. So renovations and remodels are popular right now, and those are a good time to install electrical safety devices. So a few of those, such as arc fault circuit interrupters, can protect against electrical fires from malfunctions. Ground fault circuit interrupters, or GFCIs, protect against electrical shock, and you'll find those near water in homes. So places like your bathrooms, kitchens, basements, garages, outdoors. We mentioned renovations and remodels being a good opportunity to work to install those, but really any time is a good time to make sure you're up to code and install those for your safety. So with that, I will turn it over to Sarah to get us kicked off.
Thank you, Ryan, and good afternoon, everyone. My name is Sarah Lake. I'm part of the stakeholder team, and with me, I've got a whole team of colleagues that are helping monitoring this engagement, and we look forward to talking with you throughout this workshop. Just a couple of reminders to the OPPD and E3 staff, please mute your microphones when you're not speaking and silence all electronic devices. As a reminder, as Ryan said, this meeting is being recorded. And public attendees in WebEx right now are in listen-only mode. But there will be lots of time and opportunities to take comments and questions. And so we will do that through the following channels. Throughout this workshop, we will be using Poll Everywhere. And if you have been a part of our workshops in the past, you're familiar with that. You'll be able to check in and do these questions either using your phone or computer. When we get to those screens, I'll provide instructions on how you do so. Also throughout, we'll be using WebEx Q&A. You might have heard Jamie earlier welcoming you to the group. She, along with the rest of the team, will be monitoring that Q&A chat, and we ask you, if you have clarifying questions about the content that is being covered, please use that Q&A tool at that time, and we will work to get those questions answered. We will also have a couple different opportunities throughout this workshop to use the hand raise tool. And that's where we will ask you to raise your hand if you have a question, and we'll actually have you verbalize or tell us what your questions are, and then we'll be able to respond with you right there. So there will be a couple of times throughout the workshop that we'll be able to use that tool. So with that, I guess we're going to kick it off with the first Poll Everywhere question. So we want to understand who's in our audience. So this is the 4th workshop in our Pathways to Decarbonization Energy Portfolio Workshop series. We want to know if you have attended any prior workshops. So I'm going to just flip my screen here real quick and show you Poll Everywhere. So if you could go to pollev.com/OPPD1 and then answer if this is your first workshop, if you've attended previous workshops, or if you've attended all of the previous workshops, let us know. You could also do that by text. Basically, all you have to do is text OPPD1 to 22333. And you just have to do that once to join, and we'll be able to use your phone or your computer all throughout the rest of this presentation. So again, if you could please text OPPD1 to 22333 and let us know A, B, or C if it's your first workshop, if you've attended a couple of them, maybe just one previous one, or if you are a trooper with us and have attended all of the workshops. And it looks like we have a ton of troopers here. That's great. Welcome back, everyone. And happy to see we have some first timers as well. I'll let this go for just a second. For those of you who are attending for the first time, welcome. This is going to be a really, really technical workshop. You might be interested in, after this workshop, to go to OPPD Community Connect and watch recordings of the previous workshops that we've had to just get caught up, as this is the 4th out of a series of 6. But we have a lot of troopers that makes me so pleased to see. All right, and to be a little bit more specific as to who's in the room, we would love to get to know you and know who's in the room. If you would like to share, we'd love to ask what is your name and which company do you represent. I'll flip back to Poll Everywhere, go to this next slide. And for this, again, you could just you could text in your name and your organization to that same number, OPPD1 to 22333, and just tell us your name and your organization, if you would, please, or if you're representing yourself. We're working on trying to figure out how to get participants in WebEx to be able to see who else is in the room. However, we've ran into some bandwidth issues with doing that. So everyone knows who's in the room, we just thought it would be a great idea if you could just introduce yourself, and so you could have an idea of who is in this workshop with you. So it looks like we've got a lot of people, as you're seeing it come through. I'll give it a little bit of time so everyone could, if you're slow texters like me, go ahead and introduce yourself. And I've seen a lot of names here that we recognize. Welcome back, a lot of you, and welcome for the first time to some of you as well. Just kind of scroll through in case you missed anyone, so you could kind of take a good look of who's here. I'll scroll back up, see if anyone else has entered. And we have a lot of OPPD staff as panelists as well. And I don't know if we have any OPPD staff that are attending this presentation, but again, welcome everybody. We're so happy to have you all here. And we have one more Poll Everywhere question that we'll ask. What % of customers in the United States are served by a utility with a carbon or emission reductions goal? So we'll go over to this. Let us know what you think. What % of customer accounts in the United States are served by a utility with a carbon or emission reductions goal? Thank you all for participating. Again, it's text OPPD1 to 22333. And it looks like we are coming up with quite a tie. Colton or Ryan, or do you guys want to talk a little bit about this one?
Yeah, I think we were actually a little bit surprised when we saw what this was as well. And it was higher than we thought. So the answer to this one is 71%. So 71% of customer accounts in the US are served by utilities, electric utilities that have carbon or emission reduction goals. So yeah, 71% is the answer here, and sort of good to see.
All right, and that is the first round of Poll Everywhere questions. I'll kick it back to you, Colton, for the workshop.
Thanks, Sarah. Yeah, and those Poll Everywhere questions will be valuable to us as we go through. Today's workshop, the objective is to share and seek feedback on the modeling framework and key considerations in the process. As part of that, this is a workshop that gets into some technical depth, and so we want to make sure that we have a shared understanding as we go through. And some of the content as we go through is a little bit educational in nature, and some of it gets to the more technical assumptions and the approach that we're taking. The intent of this is to make this workshop, palatable or like approachable for whoever attends, whatever your level of technical depth. And so we appreciate your attendance. As we start out today's presentation, we're going to be going over an overview of Pathways to Decarbonization as a strategic initiative. The Energy Portfolio project that we're presenting today is just one project of that broader program that we have. And then this is the fourth workshop within a larger series. And so we'll share a little bit of the context of this workshop, what we've covered so far, where the rest of this workshop series is going. I'll have some time to sort of discuss or frame the challenge that we have, talk about the overall modeling approach and the considerations that we have from the utility side as we're looking at decarbonization and as a community. Then I'm going to turn it over to Zach Ming at E3. We're going to get into some of the technical depth of how we're actually bringing all these things that we've talked about in the prior workshops together within a unified modeling approach. And so the sections of that area of today's workshop will be on the environment, reliability, resiliency, and economic modeling and optimization. Just broadly, those three topics really parallel the themes of OPPD's mission, which is providing affordable, reliable, and environmentally sensitive energy services to our customers. We have 3 comment periods throughout where participants will be able to vocalize the questions they have. So we have a comment period after the reliability and resiliency section. We have a comment period after the economic modeling section. And then we have a comment period at the very end of the workshop. Any feedback that you'd like to share as we're kind of going through this whole series and on the project as a whole, we're open and we would love to hear what you have to say. And we'll have the Q&A tool open throughout if you have questions as we're going through the content. And we'll address clarifying questions through that mechanism. For reliability and resiliency, the topics are resource adequacy, operational reliability, our focus on resiliency, and a specific resiliency study. And our topics for the economic modeling and optimization are on the overall portfolio optimization. So again, bringing all the pieces together and solving for the best solution. And then on a risk analysis, which we'll share and discuss. And so I've shared this previously. This is the charter that we have for this project. And the Energy Portfolio project will study actionable pathways to eliminate or significantly reduce greenhouse gas emissions from OPPD's energy portfolio while balancing impacts on reliability, resiliency, and affordability. And so I've shared this each time, but as a reminder, this is a study, and we're looking at a broad range of potential outcomes across that study to understand really what opportunities we have as a utility, what sort of decisions are robust for the utility, and really form a strategy around sort of the time horizon that we're looking at and the options afforded to us. So this isn't in this study we're looking at a range of different scenarios and potential pathways. We're not making specific, very detailed assumptions around retirement of facilities or where facilities will be located. And so the energy portfolio, again, is one project of 4 projects in OPB's decarbonization program. The other projects within this program are internal operations, and that's focused on really identifying OPB's greenhouse gas emissions across our entire footprint, so not just our electric generation, but across our operations, our fleet, our waste. It's also it's developing that accounting framework to quantify those, and then it's also looking for the opportunities where we can make changes in sort of day-to-day activities. That is being led by Emily Muth. The customer project is focused on specific products and whether that's demand side management, demand response, energy efficiency type of products that we can have and work with customers that actually help customers reduce emissions on their end. And so that's where a lot of the specifics of those products and programs lies, is within the customer project, led by Paul Fortney. Again, today, and we've talked about this for the last several sessions, the energy portfolio. This is how OPB's electric fleet and how we meet total electric demand with our generation resources, and as we're looking at demand, overall large levels of demand response goals as well, and energy efficiency. And then the community project is led by Emily Muth, and that's focused on how we can use the information that we're learning through this decarbonization study to work actively with the community in understanding decarbonization goals and opportunities. And so I mentioned this is the 4th workshop in the series. I think a large number of the audience have participated actually in the first 3, which is good. There's recordings available. The first one was kind of an overview of our entire workshop series and project here. The multi-sector modeling for workshop number 2 focused on if we're going to achieve decarbonization more broadly in the economy, what that means for the electric utility, as we would anticipate some of those other forms of energy consumption today, that there's a great opportunity to electrify those to help achieve decarbonization. But there's an implicit impact on OPBD, the amount of energy we need to serve, our responsibility as an electric provider, our load forecasts. Workshop 3, the last workshop, we focused on key assumptions and scenarios around the types of technologies, when those technologies will be available, the cost of those technologies. And so we also took stakeholder feedback on the types of key modeling or framing scenarios that we're looking at. Today, we're going to be focused on the technical of the modeling approach and how it all fits together. In workshop number 5 in the fall, we'll share our initial results. We'll give time to have feedback, discuss those, internalize those, and come back with the final results in workshop 6. And actually, to prove that we are listening to the customer feedback throughout, we had a request in the last workshop that was stating that going all the way from May until the fall without an update was just a long period of time. And I think there's a desire to see more and hear more from the utility as we're actually putting our heads down and going through the modeling. And so we've added an interim modeling update that we plan to have on 8/4. That we won't have results, but we'll be able to share the status of the modeling, how it's going, any findings that we may have at that point in the study. And so we welcome and encourage our participants today to join us in that session as well, if you'd like to kind of follow along with us. And I would mention one more thing, that once we develop this portfolio or the different pathways, is those pathways will directly influence OPBD's filing for its integrated resource plan in February of 2022. So our objective today is to share and seek feedback on the modeling framework and key considerations throughout the process. What we're looking for an outcome is really to develop a shared understanding with stakeholders of the modeling challenges that we have, the approach that we're taking, and any concerns or questions that stakeholders may have throughout the process. Our goal, again, as much as we can, is to provide you insight and transparency into how this works and the types of things that we're considering as planners, so that we have a shared understanding of sort of what the foundation is and how we need to plan for the future. And so as we're coming into the content today, just want to step back and sort of frame it. During the first workshop, we asked participants what they valued, what was the most important to them: affordable, reliable, or environmentally sensitive. And we actually saw that stakeholders selected and placed in priority importance each one of those. And so really there was a split across all of those different ones, or all of those different objectives. Today's conversation is really not about which of those goals is more important. Today's conversation, I'll call it a yes and conversation. Yes, we've set a target for the portfolio to be environmentally sensitive, and now we're solving for how to make it both reliable and affordable as we work towards that goal. So we think that we can actually accomplish all of those things together, and this modeling framework is what helps us understand how that looks going forward. And again, it's really not a question of if the utility or OPPD is pursuing decarbonization. Our directors have pretty clearly set a goal for that as the target, as the objective. It's a question of how we're doing that. How, from a technical perspective, we're considering reliability, how that has impacts on affordability. And so it's not a question of if, but it's a question of how. And lastly, we'll, with the information that we have today, I think we'll set out, or through this modeling effort, we'll set out a vision of how it might be achieved. But there is a great deal of uncertainty as we move through the future. Technologies are going to be evolving and emerging. Costs are going to be declining. There's really a lot, policy will be changing, and so there's a lot that will be learned. And so we're looking for, this study to really help us and support us as we sort of maintain flexibility to achieve that, and we understand kind of what's a robust direction. And so that high level, the modeling approach that we have is to meet the goal of net zero. And actually, in the last workshop, we talked about, it's not just net zero, but what's the speed at getting to net zero, whether it's accelerated, whether it's by 2035, whether it's moderated and so it's slower, but it still gets done by 2050. We're going to look at all of those different paces of decarbonization. But ultimately, what we're solving for is that net zero goal by 2050. We'll also be solving for a system that's reliable and resilient, and then we're going to be doing the economic analysis to really try to understand and communicate what the financial impact is of those potential pathways. And so getting into today's topic as well, in the second workshop, we discussed the importance of multi-sector modeling on the electric utility. And we really see electrification as a key opportunity to achieve some of that broader economy-wide decarbonization. That has impacts on OPPD's load, but it also has significant impacts on the responsibility of OPPD as an electric provider, creating a need for greater reliance and resilience than we've ever had before. As we look at electrification of transportation, as we look at electrification of buildings, customers now are becoming dependent in this future on electricity on a fully charged car, on a charged car to be able to use to get to the hospital in an emergency, or they're depending on electric heat to warm their homes, during very cold conditions. And so, there isn't the reliance on backup fuels or backup sort of technologies in this fully electrified world. It creates a greater need and a greater responsibility. Also, greater opportunity for the electric utility, but greater responsibility. And the changing energy mix that's happening nationally has been identified by NERC, which is the North American Electric Reliability Corporation, as a top reliability risk. And so it's not renewables that are causing that reliability risk. It's not the adoption of renewables. It's really understanding how those renewables fit into the overall system and how we understand the system to operate, with the integration of those. And so, we'll be discussing throughout today's presentation, renewables can and do contribute to system reliability. And the question is appropriately understanding how they do so that those reliability events can be avoided. Ultimately, it's up to, and there's a number on the call today, it's up to the planners and engineers to ensure that this future energy portfolio is able to support a reliable and resilient grid. Because we know if we don't do that and the grid fails when customers need us most, that actually could harm the speed of electrification as we're looking at electrification to reduce overall emissions. And I would say also that the planning challenge is one of the challenges. The complexities of modeling all this together, and that's sort of the first thing. But after that, there are still execution and operational challenges that need to be addressed. And so this is, these are things that can be overcome. They're things that we can work through. But this is ensuring that not only do we have enough resources for the system, but then we're looking at how those resources are built, where they're built, and ultimately how we operate the system. Is our ultimately, where will those resources be located? Is the community accepting of those resources? How can we work with the community to best place those to serve our overall needs? And so when we're going through today's modeling, we are modeling all sorts of conditions. What this graph is in front of you is a typical year for OPPD, and it's OPPD's hourly load throughout the year. And you can see that there's quite a bit of variability throughout the year, from the winter to the spring to the summer to the fall. The utility needs to plan for serving load during all of those times. During the midst of cold weather, during hailstorms or tornadoes or the heat of the summer. And those have very significant different impacts to the electric grid and how resources are operating in those times. And the question is, how do we plan for that? And how do we also minimize the emissions on a day-to-day basis throughout the horizon? Also in this is we have a static load profile. I think in the future, there is opportunity, to have greater demand flexibility, to work with customers and develop innovative solutions for demand response. So that some of this profile may be modified so that we can fit the profile to the renewable resources that we have. There's also going to be times when, customers are dependent on the grid for, basic things, whether it's communication or heating, where there's really not much flexibility to be able to shift load. And so it's really a question of how do we plan for those events? How do we understand that how these resources fit against that load, and what's the potential for that load to be flexible in the future. Those are all things to be considered in the analysis that we're going to share. And so today's conversation, we promised it would be a little bit more technical. These terms in the glossary are definitely more technical than the glossary terms that we had in the previous presentations. I'm not going to read all the definitions. It's available in the content to be able to pull up and reference. The types of topics that we're talking about: resource adequacy, loss of load expectation, effective load carrying capability, regional transmission organizations, this crazy German word called Dunkelflaute. These are all the types of things that we're going to consider that we consider as planning or as planners, and we'll kind of walk through what those are as we move through today's presentation. And with that, I'm going to turn it over to Zach Ming at E3, and we'll get into some of this approach.
Okay, thank you, Colton, and nice to be with everyone again. I'm Zach Ming from E3. We've been working very closely with the OPPD team now for several months, sort of constructing the modeling approach that we're going to be presenting today. Also joining me from E3 is Arnie Olson and Aaron Burdick, who are going to be on the line and available, probably chiming in, answering questions as well, and Colton might be chiming in and answering questions as we progress through this presentation as well. So let's get right into it. If we go to the next slide, the entire energy portfolio project we've segmented into several different tasks. You might recognize this graphic here on the left from some of the previous workshops. We had an entire workshop on multi-sector modeling at the beginning. That created some of the electric load forecasts that we're going to be using in the modeling. And then the previous workshop talked about inputs and assumptions for these middle three tasks. Today, we're going to be talking about the actual modeling approach and the way we're going to use some of those inputs and assumptions to conduct the reliability and resiliency analysis, the portfolio optimization analysis, and the risk analysis. So we're going to be getting into each of these in a little bit more detail. We have a different section on each one of these topics. If you go to the next slide. So just to refresh on the environmental approach that we're taking, the slides or the graphics here might look familiar. We introduced them at the previous workshop, but every scenario that we analyze is going to be assessing different trajectories or ways to achieve net zero. We have several different scenarios that achieve net zero by 2050 at different paces of decarbonization. So a scenario that has a straight line decarbonization approach, and then a scenario that achieves it decarbonization slightly faster and slightly slower. And then we also have a scenario where we analyze net zero by 2035 and what that would take, what types of resources in the portfolio that would take. And all of these scenarios are compared against a reference scenario where there's no greenhouse gas reduction target. And the reason we're running that scenario is so we can understand the differences of the net zero scenarios relative to a case where there is no objective or carbon reduction target. So every scenario is going to have a different greenhouse gas target or different pace of decarbonization, and this is one of the key inputs into the modeling. If we go to the next slide, so one of the most important factors in decarbonization modeling is ensuring that the energy portfolio that we produce is both reliable and resilient. And broadly, what this means is that the electricity system is able to keep the lights on across a really wide range of conditions, both sort of expected conditions and unexpected conditions, polar vortex, for example. Within the bucket of reliability, this is segmented into two primary buckets. The first is something called resource adequacy, which is quite simply just a measure of, are there enough resources to keep the lights on? Do you have sufficient resources to meet electricity demand across a range of conditions. And this is a very well-established type of modeling and analysis that's done in the industry. And so we're going to be conducting resource adequacy modeling, and we have several slides that talk about that topic. Also in the bucket of reliability is operational reliability and essential reliability services. So this portion of the analysis is looking at not just is there sufficient resources or are there enough resources, but do those resources have the right capabilities to keep the lights on? Do they have the flexibility to ramp up and down as demand is fluctuating up and down? Do they have other sorts of technical requirements that are required by regional planners and even national reliability coordinators? So that's within the reliability bucket. We'll be talking about resource adequacy and operational reliability in a bit more detail. And then on the other side, in the resiliency bucket, resiliency is an emerging topic in the electricity sector that, because of several high-profile events, folks might remember Superstorm Sandy in New York in 2012. More recently, we had the polar vortex event, knocked out Texas for several days. Some of these high-profile events that make the news have shown a light on the resiliency or lack thereof of the current electricity grid in the United States. And so there's a renewed interest on ensuring that the system is resilient to certain non-routine, really high-impact events. But unlike resource adequacy or reliability, there aren't as many well-established metrics for measuring resiliency. And so we've constructed an approach for how we're going to tackle this issue, and we have a portion of the presentation today that'll be focused on resiliency. Okay, next slide.
So we have another poll everywhere. Question, as Zach said, we're going to be speaking quite a lot about resource adequacy. So we just kind of want to take a pulse check, an understanding check right now of the audience. And I'm going to switch over to that question. We're curious at this point, before we really dive deep into it, how well do you feel you understand the topic of resource adequacy? If you could please text OPPD1 to 22333. Let us know how you feel you understand the topic at this point before we dive deep in. Or if you want to go online, again, it's pollev.com at pollev.com/OPPD1. So Zach and Colton, this is kind of feels like we've got a real smart group. Most people seem like they at least feel like they understand the basic concept. Some people aren't familiar with it right now. They will be, but you've got a pretty well understood group at this point. So.
Great. Well, hopefully even for the folks that understand resource adequacy pretty well, hopefully we have a couple new nuggets in here that folks might find interesting for takeaways. So just diving straight into resource adequacy is really a measure of, are there enough resources to meet electricity demand? Another way of saying that is there sufficient capacity to meet electricity demand? And that is most challenging when electricity demand is very high, and if electricity demand exceeds the capacity of the resources on the system. An example of that is illustrated here in this top chart. Then that might result in something called a loss of load event. So if total electricity demand is higher than available resource capacity, then the grid can't serve a portion of total demand, and that would result in some type of potentially blackout or brownout on the system. The goal of resource adequacy planning is to ensure that these loss of load events are hopefully never happen, but in reality happen very infrequently, at the maximum no more than once every 10 years. That's commonly referred to as the 1 day in 10-year standard, and that's the most common resource adequacy planning standard in the industry. The way that resource adequacy is ensured is by building sufficient capacity to not only be able to cover peak demand, but to also have a buffer of a planning reserve margin. And the planning reserve margin is there to account for the fact that sometimes generators are unavailable because they have a forced outage. Sometimes peak demand is even higher than expected. There can be freak, weather events, extreme cold, extreme heat that increases peak demand even more than was planned for. And there needs to be some buffer to cover for that. And then other types of weather conditions and normal operating reserve conditions. So broadly, resource adequacy modeling tells planners how much capacity is needed to meet the reliability standard of not having a loss of load event more than once every 10 years. And that's, we'll be conducting that analysis in this project. Loss of load analysis also tells planners the times of year in which loss of load is most likely to happen. You can see an example of that in this table here in the bottom right. And broadly, these loss of load hours correspond with peak hours, although that changes a little bit with renewables on the system. And for a summer peaking system like OPPD, those hours would be likely to occur in the summer in the afternoon, evening time period. Okay, next slide.
So it looks like we have another understanding check after Zach's slide. Let's talk a little bit about this resource adequacy. So the question is, what is resource adequacy and how is it measured? I will give you your multiple choice options here in just one moment. Again, what is resource adequacy and how is it measured? I won't read through all those A, B, C, D. I hope you can see it. And let us know what you think your answer is. Please text OPPD1 to 22333. And let us know if you think it is A, B, C, or D. Looks like C is, at this point, a real winner. I'll give people another moment or two to respond. Nothing's moving, so I bet people are all entering C. Colton or Zach, do you want to talk about that? Are they right?
Yeah, of course they're right. These questions may be a little bit too easy for the audience here, but appreciate the participation. And some of the questions we're going to move from, again, sort of this educational type of question or understanding check to some broader questions later.
Very good. Another understanding check. Let's talk about what condition can make loss of load events more likely to occur. I'll move over to that one. Again, what condition can make loss of load events more likely to occur? A, B, C, D, or E? A lot of E's, all of the above. Are we correct?
Yeah, the audience is correct once again. I think there was a comment that Zach made earlier around when loss of load events can occur, and traditionally they have happened during the peak load. That's when there's the most strain on all of the resources to meet demand. As we're sort of evaluating loss of load and as we have these models in the future, one of the considerations is not just peak demand, but really net demand. So, when is this system most strained after the inclusion of renewables? And, when's the benefit of renewables? Also, when are renewables not present or lower than expected, and how does that impact your loss of load? Changes in weather and unexpected weather, doldrums or low renewable periods, higher than expected peaks, common mode failures of generators, like a flood would happen, and multiple generators would be knocked offline. Those are all the types of things that impact this loss of load and create an inadequate supply of resources to meet electric demand. So I think the audience understands it pretty well.
Okay.
Zach?
So continuing on here. Yes.
Sorry, we do have a question that came, and I think actually we can maybe answer it. We'll just hold it for maybe once we get through these next couple of slides. But the question, just so we acknowledge the question and sort of think about it as we're going through these, is how does customer renewable energy generated on their site impact reliability and resiliency? That's a question that we received. How does customer renewable energy generated on their site impact reliability and resiliency? It's probably dependent on the type of generation and and also the customer's load profile as well. But maybe we can address it as we're going through these.
Yeah, I think that this is probably a good a slide as any to tackle that. So from a resource adequacy planning perspective, traditionally, the way that resource adequacy planning worked is by essentially ensuring that there were enough firm dispatchable resources on the system to meet peak load. So the traditional historical types of resources used in the industry like coal, natural gas, nuclear are able to generate power any time of day, any time of year for as long as needed. And so wouldn't say resource adequacy planning was necessarily simple, but it was relatively straightforward. What's your peak load plus your planning reserve margin, and then build enough capacity to meet that requirement. With the introduction of zero carbon resources that are necessary to achieve decarbonization, like variable energy resources, so that includes wind and solar, as well as energy limited resources like energy storage, for example, these resources can also contribute to resource adequacy requirements, but measuring how those resources contribute is significantly more complicated than for firm resources. If we take a look at this chart here on the top right, which has an example of solar, we can see that solar does generate during the peak hour and can reduce the residual demand that must be met by all of the other resources on the system. So we see that the first tranche of solar is producing during the peak hour. But by producing during the peak hour and lowering the peak that must be met by all the other resources, it also shifts the residual peak later into the evening. And we can see that every tranche of solar shifts the peak downward and also later into the evening until eventually the residual peak is after sunset and solar can no longer reduce the peak anymore. And so what this is effectively illustrating is the idea that each incremental tranche of solar provides less capacity than the previous tranche. The first tranche provides a significant amount. The next tranche can provide a decent amount, but ultimately the incremental contribution declines. And this is often referred to in the industry as diminishing returns. And it's a phenomenon that's true for solar, it's true for wind, and it's also true for energy storage as well, which is illustrated in this bottom chart here. You can see that energy storage can also provide energy during the peak. And when it does that, it lowers the peak, but it also elongates the net residual demand for the next tranche of energy storage must meet. And so for a limited duration resource like energy storage, if it, for example, only has a duration of 4 hours, if the residual peak period is longer than 4 hours, then energy storage might not be able to dispatch for that entire period. And so that limits its effectiveness at providing continued capacity. I think I'm having a bit of internet issues here, but I think I still have audio, so I'll continue on here.
Yeah, Zach, we can hear you. We can't see your video,
okay.
But we can hear you just fine.
Okay, sounds good. All right, so if we go to, yeah, I think that covers everything on this slide. So if we go to the next slide. So the previous slide illustrated the phenomenon of diminishing returns that affects renewable resources and energy limited resources like solar. But there's another phenomenon that's important to capture in how these resources contribute to resource adequacy as well. And that's the idea that pairing these resources together in combination can often yield more than what these resources can provide individually. So if we take an example of pairing solar and storage together, you'll recognize the two charts on the left here from the previous slide. This is showing what solar can provide for capacity on its own, what storage can provide for capacity on its own. But if you pair these resources together, we can see that the effectiveness of storage is actually increased on a system with solar because the net residual period is skinnier and narrower, which increases the effectiveness of storage because it's an energy limited resource that can only dispatch for a defined period of time. And so the combined capability of these resources is more than what they can provide on their own. If we look at an example of wind and solar together as well, we see this phenomenon repeat itself. Wind, if we look at this chart here, this left-hand chart on the right side, we can see that wind by itself is not actually very effective at meeting peak load. Wind tends to not produce very much, at least in Nebraska and surrounding area during the middle of the day. Wind tends to produce more during the mornings and the evenings. So wind on its own is not incredibly effective at providing capacity, but if we'll remember, solar, as we add more and more solar to the system, it actually shifts the residual peak or the net peak into the evening when wind is more effective. So by building wind and solar together, we can actually get more of a capacity contribution for these resources together than either of them would be able to provide on their own.
Zach,
So,
before we,
yeah.
Go ahead.
So I was just going to say, both this slide and the previous slide highlight two of the really important characteristics that are important to capture in assessing the reliability, potential reliability contribution of these types of resources. Go ahead, Colton.
Yeah. I was going to emphasize the point that these graphics emphasize or demonstrate that these resources can provide resource adequacy. They can help offset the need for generation from a reliability perspective. I think what we're talking on these two slides is around reliability and total resource adequacy. That's a different topic than is incremental solar or incremental wind useful to offset renewables, or I'm sorry, offset carbon emissions and lower the total emissions produced or the total energy intensity of the grid. They are incrementally more important, or they are incrementally valuable to reduce those emissions. This is just looking at, again, the reliability component of resource adequacy component of reliability, and not their value as energy resources.
Okay. All right. Well, I am going to keep going. I unfortunately have lost all connectivity, so I can't see the slides anymore, but I'm just going to go off what I have on my computer, and hopefully we're all lined up. So if we go to the next slide that has the 13-day period, this is a complicated slide. It's probably the most complicated slide in the deck, and so just bear with us as we walk through this, but I think this illustrates the third sort of really important feature to understand about the reliability contribution of renewable resources and energy storage. So what this chart here is showing is real data from the most recent polar vortex that happened really across the entire middle of the country this past February. What we've done is take actual electricity demand, which is the solid line at the top, and pair that with actual wind and solar production data that's been scaled up significantly. So this is way more wind and solar that actually exists right now in the Nebraska and surrounding area, but we've scaled it up significantly. But this is actual wind and solar production from the resources that do exist. And what we can see from this chart is that for the first 4 days, almost 100% of electricity demand was met from a combination of wind, solar, and energy storage resources. Energy storage is very effective because there's lots of periods, it's not exactly shown here, where the production of wind and solar is greater than demand, so that's able to charge energy storage, and then energy storage is able to discharge during the time periods when the sun is down and those resources aren't producing enough to meet the total electricity demand. But what we can see is that as we continue to march forward in this polar vortex event, electricity demand is actually increasing significantly relative to the beginning part of the period. And it's important to remind that this is actually in spite of pleas from the system operator and utilities in the region for customers to reduce their electricity demand. It was really cold outside and people needed electricity to not freeze, to prevent pipes from bursting, etc. So electricity demand is increasing, and at the same time, production from renewables is decreasing. You can see here on February 12th, 13th, wind production is very low and solar production is very low. And so there's a significant gap between what those resources are able to provide and what is being demanded by customers. And the reason energy storage isn't able to contribute here is because it's already run out of charge. And there aren't periods where there's excess renewable generation above load to actually charge the energy storage. And so energy storage isn't able to fill this entire gap because it's essentially run out of juice. And this phenomenon right here of extended periods of low wind and solar generation is this strange German term that Colton referred to at the beginning of the presentation that's called a Dunkelflaute event, which is literally a German word that means dark doldrums. Germans are on the cutting edge of renewable adoption, and so they kind of figured out this issue before the rest of the world did. But they realized that there are periods where there are just prolonged low wind and solar generation, and during those periods, there is some type of firm backup resource that's needed to fill the gap. Again, it's not saying renewables are at zero. They are providing some generation during this period, but there are prolonged periods where these resources combined with storage aren't able to fully fill the gap. And so making sure that we find these events using actual historical data of load, wind generation, and solar generation is a critical part of resource adequacy modeling to make sure that we don't unexpectedly run into an event that we haven't planned for.
Zach, I have a clarification question that's coming in on why doesn't the graph show coal, natural gas, nuclear, or hydropower? And it doesn't show that because this is what we're showing here is the load versus the renewable production, scaled renewable production of what was available across the entire SPP footprint. The wind and solar is actually significantly more wind and solar than is available on today's grid. And sort of the effect that this is demonstrating is even if you increase the amount of those resources considerably, you would still get into this issue because there are times when the wind is not producing across the region. And it doesn't mean that the resources aren't valuable. Doesn't mean that the resources aren't valuable most of the time. I think the graph clearly shows that even during these events in the first few days that renewable energy was able to fully satisfy the load requirements. The question remains of what and how is the system planned for these types of events. And so I guess this is an example where we've scaled those resources, and that's why you don't see any coal or natural gas. This is a theoretical. If you had these resources and if you had many more of these resources than are on the system today, what would it have looked like? I think that there's some thought around you can just put them in different places and you have different production profiles, and that is true. It's definitely true. just know that this wind profile already is from resources that are distributed across the entire SPP footprint region or footprint. And so, there really isn't an incremental ability in this case to add more to be able to amplify the curve when it really is not windy.
Hey, Colton, this is Arnie Olson from E3. This might be a good time to note that the other resources that were mentioned, coal and nuclear and natural gas, those resources all have limitations as well. So kind of the point of the slide is to focus on the limitations associated with wind and solar and batteries, and to focus on the fact that they just don't always produce when you need them to. It's also the case that conventional resources don't always produce when you need them to. And in fact, that was a big part of the Texas story earlier this year, was that a whole lot of the natural gas generation didn't perform as needed. And so it's going to be really important to look closely at the performance of those resources during these types of events as well in the near term while we still have them. That wasn't the point of this slide. This slide is meant to focus on the renewables, but it's also an important part of the story to understand that every resource is limited, no resource is perfect. And the point of the exercise is to put together a portfolio with a combination of resources that together will help you get through events like this.
Thanks, Arnie. I think also, there's that point around load flexibility that I think came up in a previous presentation. And I think, load flexibility might be part of the solution. Certainly not all electric energy was used to heat homes, during the event. And so conservation can be part. I think that's, part of the solution. It's just a matter of how much can that, actually, how much can customers shave at the end of the day? They still need some amount of energy for their systems. So I guess there's a lot of observations here. We had a couple of points here as well. When we're talking about electrification of systems like buildings and transportation, it can actually cause this peak load curve to grow and this challenge to become more difficult. And so we still have to plan for those types of events. And we have a number of questions in the chat, Zach. So I'm going to read some of them, and maybe we can address them as we're going through here. So the first question is, in the modeling of the polar vortex, how extensive are assumptions regarding the amount of wind and solar and capacity and storage capacity? Is it assumed that wind, solar, and battery are spread across the entire SPP?
Zach, I think you're on mute.
Whoops, sorry about that. Okay. Yes, so there's a couple answers to that question. We are providing the option for the portfolio to select resources across the entire SPP footprint. Obviously, the more geographically diverse the resources are, the more likely they are to balance each other out, because when it's windy in one area, it might not be in another, and vice versa, and same for the sun. And so that is an important value of renewable resources, but the more spread out resources are, the more transmission that has to get built to ultimately deliver that energy to OPPD. And so we're going to be providing that option in the analysis and determining, balancing those two factors against each other.
Yeah, and I guess to add on to that question, the amount of resources that we added for this example are shown in the lower left compared to that winter peak load versus how much battery, solar, and wind were added, and those were assumed to be representative of how resources are on the SPP grid today, diversified across the region.
Hey, Colton, I know we've got a couple that are particular to the graph that maybe would be helpful to others. I think one was about just that light color that goes from February 7th to the black dash line, if you could clarify that.
Yeah, that is area that is not able to be served by wind, solar, or battery storage in this example.
Perfect. And then I think there might be another one. The scaled up renewable generation capacity is over 3 times the demand, and was still unable to meet the load. Is this part of the plan costs?
So part of the study is to optimize the portfolios or the resources so that we minimize costs, and so we have the right mix. I think what we're trying to demonstrate in this example is even if you did have significantly more, you'd be challenged for this particular type of event that occurs. The costs will come in as we talk about the portfolio optimization. This isn't the plan that we're recommending for the energy portfolio. This is just an example at this point in time.
I guess we kind of skipped over the previous question that was asked about customer generation and how that can contribute to resource adequacy. And just to back up to that a little bit, I guess the explicit answer to that is we would, generally prefer to include customer resources in the same bucket as the solar that you see here on the screen, assuming that the customer resource was solar. If you're talking about backup diesel generators or something, that's a little bit of a different animal. But we tend to count behind the meter or customer resources from the entire grid scale or supply side perspective. The reason for that is because those resources are going to be impacted by the same types of events as the grid scale resources. So during a dark doldrums period, when there's widespread cloud cover, customer resources are going to be impacted just like the utility scale solar resources. So we lump all of those together. They have slightly different production profiles, but we do lump them all together, and they can provide capacity to the system and carbon-free energy to the system in the same way that grid scale solar can as well.
There's a comment or a question around how nuclear or other resources may have been able to actually meet this, and I think that's the comment around a nuclear facility would be one of those firm dispatchable resources, which is just one of the types of technologies that we're considering, along with hydrogen powered technologies or other technologies to be able to meet these types of periods. So a resource like that, it may have forced outage rates, just like any other conventional generator, but fundamentally it would have been able to provide power during this period where renewables and storage were challenged. And so I think that's where we're talking about how do you have the right complementary mix of resources so that the majority of the time you can depend on renewables, you can minimize carbon emissions, you're also able to serve load in these critical events. Okay, I think we can move forward, Zach. Just
Yep.
Considering time here.
Yep. Next slide.
Okay, so now I get the challenge of trying to pronounce this word. So we have another understanding check for you. What does the term Dunkelflaute mean? And why is this a challenge for planning? And I took French in high school, not German, so I apologize about that. All right, let's see what you guys know. Another multiple choice, A, B, C, and D. Again, text OPPD 1 to 22333. And this time we do not have a unanimous answer. So Zach and Colton, if you want to discuss.
Yeah, perhaps we talked too much after we said Dunkelflaute last. But a Dunkelflaute is a period of low solar and wind generation, and the challenge is that there's sufficient capacities required to make up for that deficit during those times. So the answer C is the answer that we were intending here.
Thank you. Moving on.
All right. So we have introduced 3 key components that we need to make sure we capture in understanding how renewable resources and energy storage resources can contribute to resource adequacy. We need to make sure we capture the diminishing returns of those resources. We need to make sure we capture the diversity benefits for how those resources can work together in ways that is more than the sum of their parts. And we need to make sure that the system is robust to certain types of events, like the Dunkelflaute events with a prolonged wind and solar, low wind and solar generation. Fortunately, there is a metric that captures all of that and more, but primarily all of that, and it is called the Effective Load Carrying Capability metric, and it is increasingly recognized within the industry as the standard metric for valuing resource adequacy of renewables and energy storage to capture all of those important dynamics. It's currently being used in California and the Midwest Independent System Operator to value renewables. The Southwest Power Pool in the middle of the country, you can see OPPD is a member of the Southwest Power Pool, will be using the ELCC metric, the Effective Load Carrying Capability metric, to value wind and solar by 2023. The PJM, the biggest electricity grid in the world, will be moving towards this metric by 2023 as well. And then in the Northeast, they're exploring this metric, and it's probably only a matter of time before this metric is the predominant, if not only, metric that's used to value how wind and solar resources contribute to resource adequacy. And the reason is because it captures all of those important dynamics that we previously discussed. So if we go to the next slide, the reliability and resource adequacy modeling for this project, we are going to be calculating the effective load carrying capability, the ELCC values for wind, solar, and storage. And these will create direct inputs that's used in developing the portfolios. So the ELCC of wind and solar and storage is a function of how many resources, how much of these resources are on the system. Because of diminishing returns, as you add more of these resources, their incremental value declines. You can see that illustrated here in the chart in the top right, which is showing marginal ELCC. As you add more resources, those values decline. But as we discussed, as you add these resources in conjunction with one another, their total value is more than the sum of their parts. And so that diversity benefit is also embedded and captured in the ELCC values that our modeling will produce. So to calculate those values, we're using a loss of load probability model, which is an industry standard class of model that calculates these outputs. We have developed our own model at E3 called the RECAP model. And essentially what the RECAP model does is simulate the electricity system under many different types of system conditions. System conditions with very high loads, with low loads, with high solar generation, low solar generation, high wind generation, low wind generation, forced outages on thermal plants or fully available thermal plants, all sorts of system conditions to understand what is the reliability of the system. Is it meeting our criteria? Does it, not have a loss of load event more than once every 10 years? And secondly, this modeling also tells us how these resources, wind, solar, and storage, can contribute to the system reliability requirements and what their ELCC value is. So we will be running this model, this loss of load probability model, to calculate the ELCC value of wind, solar, and storage, and use those outputs as a direct input into developing the final portfolios to make sure that the portfolios meet the reliability criteria. Okay, next slide.
We have another understanding check, another one about resource adequacy. We want to know, how well do you feel you understand how resource adequacy will be modeled and measured? Flip my screen. Again, how well do you understand how resource adequacy will be modeled and measured? Text OPPD 1 to 22333. So we have a lot of people that basically understand the concept but have questions. Other people feel like they're starting to grasp the basic concept, and some of us feel like we understand it and can explain the concept to others. But I think that understand the concept and have questions is kind of our most popular response.
Yeah, I'm just hoping that E didn't go down from where it was when we started. But I think it's about the same or so.
Very good. We'll move on.
And so we've talked a lot about resource adequacy. When it comes to reliability, there are other aspects of reliability, including operations reliability and essential reliability services. And so to discuss those items and how we're considering those, Steve Homan, who's our lead for our reliability and resiliency team for the energy portfolio project, will be sharing a little bit of our approach here.
Okay, hi, can everybody hear me? Okay. Good? Okay.
You're good, Steve.
Perfect. Well, hello, everybody. Like Colton said, I'm Steve Homan. I'm actually a senior engineer in transmission planning. And so just to talk a little bit about some other things that we think are very important to making sure that we can enact this thing as we go forward down any path towards net zero, is this concept of operational reliability and then also essential reliability services. So really fundamentally it's getting at how can we reliably and resiliently operate the system once we know what kind of resources we're going to have and where they're going to be. So to this point, we've talked a lot about resource adequacy, and it's critical, of course, but it doesn't capture all the complexities that we face when planning out a reliable bulk electric system. And so really that speaks to how do we interconnect all these resources and bring them to load through the electric system, so the transmission system, distribution system. So we need to consider, at the national level, NERC reliability standards, so that helps us kind of make good decisions and operate in a way that supports the bulk electric system. And then regionally, kind of at the Southwest Power Pool level for us, we follow their requirements and play by those rules. And then definitely locally, we bring in any kind of local OPPD level considerations. And so, we've gotten a flavor here in the previous slides, around loss of load expectation, LOLE, and ELCC, the effective load carrying capability. And that diversity of resources has a big benefit. And so not only diversity in the resource mix, but also location too. So as we start to think about kind of the next set of slides that we're going to get into about resiliency, we need to understand the challenges that we face there. And so the key to us being able to understand those challenges and how this all fits into an ever-changing electric system and world around us, that is key. Very important. And so, we're seeing that right now today. We are in SPP and we participate in all those planning efforts there. And we're seeing, a significant amount of generation resources, including a lot of renewables that are trying to get built. They're running into issues where there's, significant transmission upgrades that are needed. And so we are trying to bring some of that perspective into this study so that we kind of position ourselves for that expectation. So kind of can't have one without the other. We can't build resources, but then not get them to our load. And so, you know, what we've been able to do is kind of do some stuff on our own and then partner with E3, obviously, in the study. But on our own, we've performed kind of some preliminary screening work to help inform E3's models. So recap and resolve, you've heard about those in previous workshops. And so what we've done there is to kind of inform, you know, what our transmission capability is today. So around, you know, really that's around import limits. You know, points in time where OPPD is most at risk for reliability is points in time where we're not serving load with resources nearest to our system. So the points in time where we have to rely on imports even more. And then we're also kind of capturing some of those transmission upgrades and cost assumptions for new resources. And then within the study, we've got some touch points kind of later on as we start to see some results from the modeling where we're going to evaluate operational reliability and use those screens and looks to help kind of make adjustments in the portfolio of resources to the extent that we need to, that we can kind of lean the pathway in a direction that you know, sets us up for less surprises in the future as we go to build this stuff out. So kind of using a variety of tools there. And then after the study, you know, as we move forward into the future and along whatever pathway that we choose, you know, we'll see things as they come into focus. And so as we get to those decision points, we'll be doing a whole lot of additional, you know, more detailed analysis. And Colton kind of touched on this earlier, is, you know, really where are these resources physically located and what do we need to do and build in order to utilize those resources to the fullest extent and make sure that we're able to operate reliably. So just wanted to kind of mention that kind of from that other perspective. So thank you.
Thanks, Steve. You know, and a lot of this discussion is the type of analysis that requires a lot of detail over the time horizon. And so, you know, these are the things that we would need to conduct after the study, really to be able to ensure that the different options or pathways that we're looking at are actionable. So thanks, Stephen. With that, I'll turn it back over to Zach for discussion on resiliency.
Okay. So clearly there are a lot of different dimensions to, as we call it, keeping the lights on. Resource adequacy is one, operational reliability is one, and the third and final one that we're going to be tackling in this project is resiliency. And as we mentioned at the beginning, resiliency is really an emerging topic in the industry, making sure that the electricity system of the future is robust and is prepared for, can withstand, can respond to, can adapt, and can quickly recover from really non-routine, high-impact events. And again, there's lots of examples of what these non-routine, high-impact events could be. It could be extreme weather events. It could be fuel supply disruption, either caused from a natural disaster or some type of hack, cyber issue, or Mother Nature, low wind and solar output events. So there are lots of different examples of this. I think we have an outstanding question here of what other types of resiliency events should be considered, and that's, I think, something that we're keen to get stakeholder feedback on in this project. So, we go to the next slide. We want to introduce how we're thinking about resiliency and how we plan to tackle it in this project. Again, given that there really isn't an industry standard method or metric to measure the resiliency of an electricity system, you know, there's an established way of measuring the resource adequacy of a system. You can simulate the system and you can say, okay, the system is good all but one day every 10 years, or one day every 20 years, or one day every 5 years. There really isn't the same parallel or analog for measuring the resiliency. And so the way we're planning to tackle resiliency is to identify specific resiliency events. And you can see some of those events listed here, like a polar vortex, a tornado, flooding, fires, or fuel supply disruption. And we're going to identify those events, again, open to stakeholder feedback on what all the full spectrum of events we should be considering are, and then assess the performance of the generation portfolio under each of those events. So assessing how do these events affect particular types of generators? What's the magnitude of the impact on certain resources? How long might those resources be offline? Those types of questions. And then depending on what we find, thinking about how to correct for those factors or improve the resiliency. And in that vein, there are really two options to improving the resiliency of the electricity system. The first is just grid hardening or adding resiliency infrastructure. So this could be things like adding winterization to plants. And you can add winterization to renewable plants like wind turbines to make sure they don't ice up. Natural gas plants sometimes need winterization. We saw that in Texas and other parts of the country this past February. Other types of resiliency investment might be something like levees around power plants to protect them against flooding. So that's sort of one bucket of options is resiliency infrastructure, grid hardening. Another option to improve resiliency is just to modify the portfolio. So if we determine that there's some unacceptable or unmitigatable risk, or maybe a risk that is too uneconomic to rectify from resiliency risk, then we might just modify the portfolio to reduce that risk. So for example, if we determine that the risk of wind turbine icing is too great and can't be satisfied with winterization, then we might modify the portfolio away from wind and towards solar or towards more distributed resources. And that's a complete example, not even saying that we're going to do that, but that's an example of how one might think about addressing that type of an issue. So we're going to be broadly assessing the resiliency of the portfolios produced in this project, contemplating ways to improve the resiliency, but we do view this work in resiliency in this project as a foundation for analyzing this for OPPD, and we definitely expect this to continue as OPPD marches down the path of decarbonization, and particularly starts to actually execute real projects in the pipeline and bring those new projects online. Okay, next slide.
Okay, so we are moving to another couple rounds of some poll everywhere questions, and the hand raise public comment period is coming up soon too. So if you have those questions, kind of keep those in mind and comments, and we'll be taking those very soon. So, but first we want to just hear from you a little bit about OPPD is committed to maintaining a reliable and affordable energy system as we progress towards a net zero carbon production. To illustrate the importance of this imperative, how would you characterize your level of concern of if power is unexpectedly and momentarily interrupted? The key here is momentarily. We're going to ask you in the next question if your level of concern if it is interrupted for multiple days. So first, when I switch over to poll EV, let us know please, if your power is unexpectedly and momentarily interrupted, what's your level of concern? A, B, C, or D? From being a nuisance, but my household can manage, to a potentially life-threatening situation if it is momentarily interrupted. Good feedback. So far, it looks like it's a nuisance. It's a significant disruption to my productivity. We understand that very much. Very good. Zach, Colton, do you guys have any comments here before we go on to the multi-day? No?
I don't.
Okay, very good. So again, we're going to illustrate the importance of this imperative. How would you characterize your level of concern if power is unexpectedly interrupted across the region for multiple days? And this might be different. So let me move on, see if you guys, if it changes your answer or not. Again, what's your level of concern if it's unexpectedly interrupted across the region for multiple days? Look at how that flip-flopped. Now it's becoming a major concern for health and well-being, a little bit of a significant disruption, but for some of us, it's even a life-threatening situation, potentially.
Yeah, I think that's a little bit of what we're discussing when we're talking about grid reliability and resiliency is how are we protecting against, you know, these multi-day type of events, these very significant events across the region, you know, as opposed to maybe more local reliability issues.
Okay, and to go into a little bit more detail about this, we're looking for more feedback. And this is going to be kind of a fill in the blank, kind of describing your own words, what concerns you have about future grid reliability, particularly resiliency threats and the impact of prolonged power outage from these resiliency events. So again, I'm going to flip back. And this is one that you'll text into us. Again, text OPPD 1 to 22333. You're probably already there. And let us know in your own words what concerns you about future grid reliability, particularly resiliency threats and the impacts of prolonged power outages from resiliency events. These might take a little bit longer for someone to type in. Here we go. Extended blackouts during severe weather events similar to what happened in Texas. Confident that OPPD can manage the risks appropriately while still decarbonizing at an accelerated pace. Oh, and they just keep on coming in now. I'll try to kind of scroll so we can see them. Thank you for your participation. We'll let it go just a moment longer in case there's any more. Kind of scroll through one more time. Zach, Colton, do you guys have any comments about all this good feedback that we're getting before our next thing will be going into the public comment portion? And yes, we are saving all these good comments. Thank you for that comment.
Yeah, no, Sarah, I think, you know, we can pretty clearly see the importance and the concerns that customers have. I think, you know, that's why we're focusing on the detail and the rigor of the modeling that we're doing at the same time that we're pursuing decarbonization. So, you know, be rest assured that this is a primary focus of this study and our transmission and system planners to come.
Going to scroll up to see if there's any that we missed. Yep, we're saving them. And so we will move on then to the public comment portion. So now is the time. If you would like to verbalize a comment or verbalize a question, we'd love to hear from you. Please click on the participant icon, open the attendee list. Then you scroll down to the bottom of the attendee list and click the raise hand button. then you click the raise hand button again to lower your hand after we call on you. And if I'm not sure if we have any telephone users on, but if we do, you can dial *3 to raise and lower your hand. Do we have any hand raises? Can we tell?
I don't, actually we do. Just got one from Mr. Andy Knott. We could unmute Mr. Knott, please.
Thank you. Can you hear me?
We can. Go right ahead.
Yeah, hey folks, Andy Knott with Sierra Club. I'm just curious, and if I missed this, I apologize. When you were talking about the resiliency exercise that you're going to go through, I assume we'll see some definitions for those resiliency events, such as duration, how many megawatts are out of service, things like that. And so that's my first question. And I guess the follow-up would be, how will you ensure that those assumptions that you're testing against are both realistic in terms of what we could expect? Well, I guess that's the main question: is how will you ensure that an event that challenges resiliency is sort of a realistic assumption?
Thanks, Andy. I'll start, Zach, and then maybe you can add on. Our modeling is going to start with the resource adequacy modeling, and then after we sort of develop portfolios that we think are resource adequate, then we're looking at it from the resiliency framework. As we're developing that resiliency framework, I think we fundamentally understand that it is very difficult to quantify some of these very rare and extreme events, and so we need to be cautious in how those influence the portfolio formation. So we are planning on compiling that list of aggregated resiliency threats that are being considered. I think mostly it'll be a qualitative discussion at that point, and we'll be able to share what that resiliency threat analysis looks like, as we conduct that study, and the considerations that we're taking in as we go through the next workshop in workshop number 5. And Zach, feel free to jump in there.
Yeah, I think that captured it well. There really aren't industry standard metrics, so it is going to be a qualitative analysis. I think it's going to be qualitative in just assessing comfort with these types of events, as opposed to saying, oh, we think a tornado happens exactly this often, and this is the exact impact of that. So.
All right, thank you both. I do have another hand raised from Mr. Alan Bavolka. If he could be unmuted, please.
Hello.
Hi, Mr. Bavolka. Go right ahead. We can hear you.
Okay. First, I'd like to mention for people who joined through the web online version of WebEx, the hand raise function is not under participants. You have to go to more and find a hand raise there. The comment I wanted to make was in response to the question about what other resiliency events should be considered. And one that I'm concerned about is, as other utilities decarbonize and don't do as good a job as OPPD does on reliability and resiliency, there could be events on the grid outside of OPPD's territory that could be resiliency events that affect OPPD as well. So I hope that that's going to be looked at.
Yeah, that's certainly a good point. We actually have in a couple of slides talking about how we're thinking about, modeling what's happening outside of OPPD with all of their neighbors within the SPP market, and we are absolutely intending to capture the changing resource mix in those other regions, jurisdictions. So we fully expect other places, neighbors of OPPD, to be adding a bunch of wind and solar, retiring other resources as well. And so we want to capture those events to the best we can.
Can we remind you to unraise your hands, please?
All right, looks like we can take one more question maybe via the hand raise, and then we'll have other options to do so towards the end as well. I've got one here from Mr. Ben McGill. If he could be unmuted, please.
There, can you hear me?
We sure can. Go right ahead.
Awesome. My comment is just that reliability and resiliency are my #1 concerns. Whatever way we can realistically do that while getting to net zero is awesome. So I like seeing this modeling. My one question, just for informational purposes, where can I find the assumptions you guys are going to throw in the model?
Yeah, I can take that. So we're actually going to publish a data release to the fullest extent that we can. We'll include the assumptions that we talked about in the last workshop on technology costs and availability. There will also be some incorporation of the ELCC values that are being considered. And I believe our date for that is one second, let me just verify. It is
June 18th, I think.
June 18th, yep. And if there's follow-up questions after that, there's a period where you can provide written questions to us.
Okay. Mr. Welsh, I saw that you had a chat in there. If you wanted to raise your hand, you just go down to the participant section. As it was mentioned by Mr. Vivoka, I think you might have to click on more, and that allows you to raise your hand. But we'll go ahead and unmute you now and you can ask. And then I think we'll move on after this one to make sure that we can get to the rest of the slides, because we do have more opportunities for hand raises after that. Go ahead, Mr. Welsh.
Testing.
We can hear you. Go right ahead, sir.
Okay, thank you. I was just wondering, with your modeling, how are you modeling what kind of extreme weather events will happen, and how far in the future are you going to do this modeling? Because the climate is changing so fast, I don't know how you could model it too far into the future.
Yeah. So right now we are planning to rely on a very large, extensive set of historical weather data. So we have temperature records back for the past 50 plus years that can tell us a good deal about what future demand might be as under a changing economy, under electrification. In addition, we do have an extensive historical set of wind and solar data, and we can match that with historical weather data, load data, to understand how wind and solar work together with load, how those three are correlated to each other. As far as incorporating climate change impacts, I think that's probably one of the pressing, sort of not fully explored areas of the industry right now. And so that's something we're going to be considering, but we aren't currently planning to incorporate climate change impacts on electricity demand forecasts.
Zach, I do have one additional comment. There was a question that we had on the data availability. I said that that'll be available 6/18. That'll be posted on Community Connect. OPPD Community Connect is where you'll find more information on that data release and where it's available. And with that, we have sort of limited time here, so I think we need to move through the rest of the content, and we can handle or address comments or concerns as we get to the end of the presentation.
Okay. Okay, so, and with that, we really get to where everything we talked about in the previous workshops and the beginning of this workshop culminate, which is actually developing the portfolios. The name of this whole initiative is Energy Portfolio, and so this is the phase of modeling where we actually construct and develop the portfolios. To do that, we're going to be using an optimization model, and that optimization model will select portfolios, and it will ensure that every portfolio meets the environmental greenhouse gas reduction targets for that scenario. So again, there's multiple greenhouse gas reduction trajectories we're considering, sort of an accelerated pace, moderated pace, or even a net zero by 2035. So there's going to be multiple scenarios we run on the environment front. Every portfolio that we develop is going to meet the reliability criteria, ensuring that we can keep the lights on all but once every 10 years. So extremely reliable system in line with today's industry standards. And the portfolios we develop will be able to meet both of those environment and reliability criteria, and the model will select which combination of resources or which portfolio of resources can provide that at least cost. And we'll be able to run a bunch of different scenarios using different assumptions about which resources might be available in different scenarios and what those resources might cost. So different scenarios are going to have different portfolios, but every scenario that we run is going to meet the environmental targets of that scenario. It's going to be reliable, and for those assumptions, it's going to be a portfolio that's the least cost option. So if we go to the next slide, this is just a little bit of an overview of optimization modeling. Broadly, when we say optimization, what the model is optimizing for is, as we previously said, it's cost. And the two primary cost components are fixed costs of building new resources. So this is the steel in the ground cost of new wind and solar resources, new battery storage, new transmission, et cetera, as well as variable costs, which is the cost of actually operating the system. So to the extent that the system is relying on natural gas or coal, those are fuel costs that are required to operate the system. A lot of zero carbon resources like wind and solar actually are free to operate. And so the variable costs for those resources are relatively small. And so the way the model minimizes cost is by making decisions about which resources to build. So it's making decisions about which resources to build, as well as for the resources it does build, how to operate those resources. And so those are the two primary levers that the model is actually playing with when it's trying to determine the optimal portfolio. And it does all of that underneath a set of constraints that are non-negotiable. So as we said, every portfolio has to be reliable. It has to meet the carbon reduction targets. And we can't build more wind and solar than is available in any certain geographic area before you move on to different areas that require more transmission builds. So there are certain limitations within the model, and the model will satisfy all of those limitations or constraints, and it will develop an optimized least cost resource portfolio that meets all of that criteria. So if we go to the next slide, the model that we're going to be using to perform this optimization is a capacity expansion model called Resolve. It's a model that we've developed at E3, and it's a model that we've used really across North America to perform very similar types of studies. Some of the sort of states and provinces that were out on the leading edge of figuring out decarbonization and analyzing what it's going to take, like California and New York, for example, we've used this model in those areas and gradually have expanded to more and more jurisdictions. And the Resolve model is really a model that's tailor-made and built for this question of, the specifics of a highly renewable, deeply decarbonized system. So it is very well suited to capture, the unique aspects of a system that's running on very high penetrations of wind and solar. And broadly, what this model does is it takes in all of the inputs that we've previously discussed. So the load forecast, going back to the multi-sector workshop, it takes that in as an input. It takes in the different technology options and what those technologies cost as an input. It takes in the reliability contribution of wind, solar, and storage. And that goes into this reliability module that you see here on the bottom left. It takes all of those inputs and it performs optimization to output an energy portfolio over time. And it tells us, what resources are optimal, how much of those resources are needed, when those resources should be built, and what the total cost of the system is. And so broadly, this is where everything comes to roost, and how we put everything together to develop the energy portfolio for each scenario. If we go to the next slide, there were some comments previously about how OPPD is going to be interacting with the rest of the Southwest Power Pool market. Again, OPPD is just one member within the Southwest Power Pool market, and so it can trade electricity, buy and sell electricity from other members. We are planning to explicitly model other loads and resources on the SPP system and capture how those systems are going to be changing as well over time. Presumably significant amounts of wind and solar additions as well, just like OPPD, because those neighboring jurisdictions are subject to the same policy and economic trends as Omaha. But there are limitations in how much SPP can trade with neighbors. There's physical limitations on how much the transmission system can transport back and forth. And there are carbon implications when OPPD buys energy from the rest of the SPP market. There's some assumed carbon associated with those energy purchases. And then finally, from a risk perspective, we're proposing as well to impose annual limits on how much trading OPPD can do with the rest of the Southwest Power Pool market, just given the fact that a system that is highly dependent on either buying or selling energy from the rest of the market has a high degree of risk exposure if the market turns out not as expected and OPPD is not as self-sufficient as we might like. So that is briefly an overview of that. And then if we go into the final section here, risk analysis, if we go to the next slide. So again, there are a number of uncertainties for handling risk. What we're going to be doing is looking at a number of sensitivities for different input assumptions around inputs like what the electric load forecast is going to be, what resource costs are going to be, what policy is going to exist for carbon or greenhouse gas reductions. And we're going to develop an optimal resource portfolio for each of these different sensitivities or scenarios. And so this will provide information about what types of resources are low-risk resources or low-risk investments. Resources that are part of the portfolio under a large number of scenarios are relatively low risk. Resources that only show up in very limited numbers of scenarios that require a very specific set of assumptions for how the future of the world plays out tend to be more risky. And so this scenario analysis is going to inform broadly how we think about risk. And so with that, we can just get through the next slide. I want to leave a couple minutes here for questions. So to summarize, we're going to be conducting the ELCC, the Effective Load Carrying Capability Analysis. That provides a set of inputs into the portfolio optimization along with a whole other set of inputs that we've talked about in previous workshops. The optimization modeling develops those portfolios, and then we develop optimal portfolios for many different scenarios in the risk analysis to determine how those portfolios differ depending on different assumptions. So with that, I think we have a couple minutes here for questions.
Do we have any more hand raises? Any more questions you'd like to verbalize at this point? I think that I have the instructions here, but as Mr. Vivolka explained, you might need to go to more if you're on the web to find your hand raise. So I don't know if we have any hand raises right now. All we have
Sarah.
left. Oh, sorry. Go ahead.
No, I can answer that. We did have one from Mr. Corbin, but he has put his hand down, and I think Mr. Knott might still have his hand up from the previous one.
Sarah, Jamie, I think we'll take a couple of questions here, and we'll move through just considering that we're close to 6 o'clock. We'll move through the next steps after those couple of questions,
Sure.
and then we do have the time to stay on for whatever questions individuals have.
So to clarify, Mr. Knott, do you still have a question, or was that from the previous one, sir?
I do not. It shows my hand is not raised on my end, so I'm not sure what to do.
No
I'm fine,
problem
thank you.
whatsoever. No problem whatsoever. Okay. Looking, fellas, and I don't see any others at this time.
Well, we can go ahead and go through the next steps basically, and then if there are additional questions, we will, as Colton said, take them at the end of the presentation as long as we need to. So I'll move on to the next slide.
So we're going to continue to take written comments on last workshop number 3. That's the technology or the key assumptions presentation, and we'll take comments on that up until May 28th. The data release will be provided on June 18th, and that'll include some of the details on the costs and specifics of technologies and how they're being considered in the modeling. Public comment will be open on that data release until 6/26, and then also we're keeping feedback open on this workshop up until 6/7 if individuals have written comments to provide to us.
And just as a friendly reminder on that, all of this will be available on opbdcommunityconnect.com. We have a special section devoted to these decarbonization workshops, and there's a special page called Workshop Recordings and Feedback. And that's where we have all the recordings posted from all of these workshops, as well as where we're taking this comments from workshop 3 through May 28th and from workshop 4 through June 7th. So please visit us on that website and let us know your thoughts.
And then the next, oh, go ahead.
No, sorry, Mr. Volk had his hand up earlier, but I think there might have been an issue with it, so I wanted to make sure we got to his question. If he could be unmuted, please.
Hello, I wanted to ask about the scenario that was described, getting down to 80%, 90%, 95% decarbonized. There wasn't any specific mention of if that was just for the year 2050, or I'd like to see those options listed for multiple years.
Yeah, that's a good question. So for those particular scenarios, those were just referring to 2050, but you'll see that in our base case net zero, there's a trajectory to get there. So in our accelerated case, for example, we'll be getting to 80% and 90% significantly before 2050. And for our 2035 net zero case, we'll be getting to net zero by 2035 and getting to 80 or 90%, even before 2035. So we don't have specific scenarios for those, but those will be implicitly captured in the scenarios we have.
Okay, thanks.
Okay, so we're wrapping up today. We're wrapping up workshop number 4 on the modeling approach. The next workshop we have is workshop number 5, which will be later this fall, where we'll share our initial results when we come back and have completed all the modeling. But we would also invite you to join us during an interim modeling update that we're planning for August 4th. We're not going to be sharing results at that time, but we'll be sharing sort of status of our modeling activities, any challenges that we're encountering, and sort of overall trajectory of our work. And then, later at the close of the year, we'll have our final results after we've incorporated feedback from the initial results, and that'll feed the integrated resource plan filing that'll be filed in February of 2022.
And just to reiterate the next steps, again, we're committed to continued stakeholder engagement and feedback. So we'd like to know how you think we did. So after this workshop, you'll be having We'll be asking you to fill out a survey, and you'll get that 2 different ways. When you close out, you'll see a safe pop-up option as you leave the meeting that is to our survey, and we'd just love you to take a few moments and fill that out and tell us how we did. We do read all of the surveys, and we take your feedback to heart and helps us plan our next workshops. Also watch your email if you miss it on the pop-up option. As Colton said, to reiterate, August 4th is that interim modeling update, so mark your calendars. We'll be posting more details regarding times and how to log in on OPPD Community Connect. And then again, the workshop 5 and 6 dates will be to be determined. Again, OPPD Community Connect is your platform to stay updated with this project, your workshops. It's where we have recordings of all of the workshops. This workshop recording will be posted by Friday, if not before. And then we'll also have opportunities for your feedback. You'll have opportunities to ask questions on that platform if there's something that came to you after this presentation that you are dying to ask us. Let us know your question and we will get back to you. Also, if you are interested in having us speak to your group, please find us at oppd.com/speakersbureau, fill out the form, and we can arrange a presentation.
Sarah, I might also add that the interim modeling update that we're planning on having on August 4th is a direct result of some of the recommendations and feedback that we received in the last survey after workshop number 3. So we read through all of those and appreciate the comments as we go through.
Thank you, Colton. Workshop number 3, you also reminded me that we are taking feedback from workshop 3 through Friday. So if you have not provided us feedback from workshop 3, please visit OPPD Community Connect, find that feedback workshop recordings and feedback page. Let us know your thoughts on workshop 3. And while you're there, you could still leave us more feedback on workshop 4 as well. But you have until the first part of June to give us additional feedback on this workshop. So just a little plug for that. I will move forward to give you another opportunity. If there are people that still have questions, please do the hand raise. I think you know how to do it by now. Do you have any general feedback on the energy portfolio project work? We will stay on and answer those questions for you. I guess I could describe, especially for telephone users, I don't know if we have any telephone users on. Please press *3 to raise and lower your hand. And again, as Mr. Bavolka said, your hand raise might be under more if you are using this on a computer, but otherwise the instructions are there. Do we have anyone with a raised hand?
I've got a question from Mr. Corbin. Go ahead, Mr. Corbin, you've been unmuted.
Thank you. Can you hear me?
Sure can.
David Corbin, Nebraska Sierra Club. I just wanted to acknowledge the hearing that all types of energy have pluses and minuses, and that it's not just wind, solar, renewables. As you know, we had a nuclear plant that was down for years. Recently, of course, there's been hacking of a gas line. And so I realize that those things aren't easy to predict, but when I watch the OPPD president's report each month, I noticed that coal plants are often, not often, but they have to be down for maintenance. And so everything has pluses and minuses. And I realize that because we're trying to work towards zero carbon, you're talking more about renewable energy and storage and so on, but I want to make sure that it's made clear that that there is no perfect energy source.
Yeah, appreciate that comment, Dr. Corbin. We have, we do actually expect in our modeling, or we will include that there are times that those units are forced offline. And so, we to some extent have, are considering those resources as not perfect. And that's really sort of the value of this integrated ELCC or loss of load modeling that we're doing. But, I think we'll take that into consideration as we're moving through our resiliency analysis as well.
It doesn't look like we have any more hand raises. Just the one final question in the chat if we wanted to cover that. Concerning future risky sources being considered, are they being modeled with diminishing risk costs in the future as the tech matures? And then there is a follow-up.
Jamie, I'm reading the question here. So is the future risky sources being considered, being modeled with a diminishing risk cost in the future as the tech matures? So we shared sort of in our previous key assumptions and scenarios presentation that we actually are considering the costs of emerging technologies are declining, and we have scenarios where the costs of those technologies are actually declining at a faster rate than even what the National Renewable Energy Lab is predicting. And so we are capturing, to some extent, the cost breakthroughs of those technologies.
Thank you, Colton. I think may just be a follow-up to that. Well, with the proposed infrastructure bill stating that there is a potential increase in transmission connections, is this being considered?
Zach, do you want to take that? I'm not.
Yeah, I can take a shot. I guess we're not planning right now to explicitly incorporate the infrastructure bill into the analysis. We're definitely going to be looking at transmission connections and the cost of increasing transmission as necessary, either because load is growing or because we're building more renewable resources that need to be brought to OPPD. So we're just looking at the physical cost of that infrastructure. And to the extent that there might be some federal subsidies that help offset that cost, then that's great, but we're not planning to incorporate those subsidies, for example, into the analysis.
Thank you both. I think any additional hand raises are just from previous questions asked. I reiterate what Sarah, Colton, and team have mentioned about visiting us at oppdcommunityconnect.com for additional feedback. We're always there. We're always looking for your engagement. I think that takes care of our questions.
Okay. Thank you to everyone who joined us today. Great questions throughout.
Thank you for your participation.